In this potassium video, I'm going to show you some pure potassium in water, unlike in my last video, although I still show you pretty small quantities. Potassium is an alkali metal, so in metallic form it is of course very, very reactive and and liberates hydrogen gas in water and makes potassium hydroxide. H2O plus K makes KOH plus H. Or if you should double all the amounts so it's actually molecular hydrogen. But anyway, potassium as an ion, once it's lost that electron that it really wants to lose, is very, very stable because so much energy is actually released when it loses that electron. So potassium as an ion is key in your body and helps regulate many things, including heart rate and therefore blood pressure. Bananas are said to be radioactive, and this is somewhat misleading because yes, they are radioactive, but so is everything else that you eat. They're just a little bit more radioactive because they have a lot of potassium in them, and potassium, a very, very, very small amount of the naturally occurring potassium is a radioactive isotope of potassium, potassium-40. Now, even though it's such a small amount, the potassium-40 is quite reactive, and potassium-40 actually contributes a fair amount to background radiation. Because of this, bananas are slightly more radioactive than usual, but still quite healthy to eat. Now, potassium, being an alkali metal, is an extremely good reducer, and I haven't actually done any experiments in the lab where I needed a reducer so strong that even sodium wouldn't work. But there are certain situations where you need a really, really strong reducer, and potassium is great for that. Potassium also, because it reacts with water, it along with sodium can be used as a desiccator, or something that removes water and air from various contraptions. Sometimes it's used in vacuum chambers to remove the last little bits of water and air that the vacuum pump couldn't remove. It, with sodium as an alloy, form what is known as NaK, Na for sodium, K for potassium, in ratios of 77% potassium to 23% sodium. This alloy is liquid at room temperature. And I actually tried to make some of this alloy, but my mineral oil had a little bit of water in it, so they formed hydroxide layers really fast, and the spheres of the different metals would not come together when I melted them. And so I ended up dumping the whole thing in water. The sodium and potassium had formed tiny little spheres with oxide coatings on them, so as I stirred around all the little spheres of potassium and sodium, they reacted in a staggered fashion, not all at once, which was kind of cool. Now, 23% sodium, 77% potassium is mostly potassium you'll be seeing, but you'll also see some yellowish flashes, which are sodium. The whitish purple flashes are potassium.